Tim, I'm going to let you kick us off and share with everyone about Aerospike.
Perfect. Thanks very much, Stacey. Appreciate it. And thank you, everyone, for joining today. I appreciate that you taking the time. And as Stacey said, we're going to be talking about Aerospike. It's going to be sort of an introduction. What is Aerospike? Why do people use it? Why is it so powerful? Maybe you've heard some unbelievable claims out there about the speeds and scales it can do. And we're going to touch on that and explain sort of why it can do it and how it does it and what's so different about Aerospike. As Stacey said, please, if you have any questions, put them in the Q&A. We'll be very happy to try and get them either as I'm talking or offline, one way or the other. So my name's Tim Faulkes, as Stacey said. I'm the Chief Developer Advocate at Aerospike. I've been working with Aerospike for about 8 years now and seen a lot of different implementations, a lot of different customers in different verticals and things like that. So it's my pleasure to go through and give you sort of a high-level introduction to what is Aerospike. So Aerospike has a lot of features. One of the best things we're known for is real time. We want to make sure that when you have an application, you want to be able to load as much data as you can in a short time frame as possible. Now, real time means different things to different people. We are renowned for running in things like ad tech, where a few milliseconds is too long. They need to be able to retrieve information in millisecond or sub-millisecond timeframes. So real time is that I really need that information now, and I need to be able to do my reads and writes and ideally get them all sub-millisecond. And Aerospike is really renowned for doing that. We'll look at how we can do that. Now, that implies that we have low latency. The low latency to us is sub-millisecond. And typically, depending on the customer and the use case and what they're doing, it's not abnormal for us to see customers who get, say, 99 to 95% of their transactions or sub-milliseconds across reads and writes. And I'll touch on how this happens. What's so unique about the Aerospike architecture that allows us to do this? And when I talk about those sort of numbers, I'm not talking about just some data. You know, it's very common in database patterns these days to have a set of data that is hot and it gets stored into a cache, and the rest remains in slow data. And if you get a cache hit, great, you get hot data and it's really fast. But if you miss, you get really slow data because you've had to go off to persistent storage. Aerospike doesn't have a cache. It doesn't need it. The numbers we're going to talk about today are the times it will take if there is no cache. We also want to do high throughput. It's great being able to do low latency, but if you can only do 1,000 transactions a second, that's not very useful. So we have customers in production who do tens of millions of transactions a second, day in, day out, sometimes bursting to 20, 30 million transactions a second. So it's incredibly scalable and gives you that ability to have very low latency at very, very high throughputs. So that's good. I mean, we're not unique in these. Low latency and high throughput can be achieved by other databases. And typically those databases run in memory. They have to get that sort of speed. Now, our architecture is different. We don't put a lot of data in memory. As I said, it's not cache. And therefore it's very scalable, and it'll be scale up and scale out. And so we have customers in production who have petabytes of data, and you don't need petabytes of data to use Aerospike. You can start with megabytes or gigabytes, but know that it will grow up to those petabyte levels. And typically, when you're running at petabytes, we have customers who have petabytes of data who are getting sub-millisecond access time on any record, not just ones in a small amount of cache, but on any record. When people think of performance, they say, well, to get performance, you have to sacrifice consistency. We are a NoSQL database, but most NoSQL databases, if you think of something like Cassandra, for example, run in availability mode. They prefer availability over consistency. Aerospike is fairly unique in that we are immediately consistent and we can guarantee strong consistency. So even under network splits, we will not lose data. You can put financial information in here. You can put information that should never be lost under any circumstances and know that it will remain consistent, and that consistency does not impact performance with Aerospike. It's also multi-model. You can see on our graphic on the right here that we've got different ways of accessing the database. Fundamentally, we're a key value database. We have one key and a value, and the value is more like a record in relational terms. It's broken up into effectively columns so that you can store multiple pieces of information inside a single record. It's not a single key, single value. It is a key to a record style. However, our records are complex. They can store lists and maps and other information. Those can be nested hierarchically. And when you combine that, effectively what you've got is a document. You've got the ability to read and write information in a hierarchical manner and store arbitrarily complex, unstructured data inside Aerospike as a document. We also have the ability to access Aerospike through SQL, for example, using something like Presto or Trino, which gives us the SQL ability on top. We're working on a graph implementation. It's in beta release at the moment, but soon we'll be coming out with a graph application on top of it. And the beauty of Aerospike is because it is so fast and so scalable, all these other paradigms work really well using that key value database as the underlying store to be able to store information in whatever format you need. We call it a data platform. I mean, it's a database, but it's so much more. It gives you all sorts of features and functionality around it. It has a whole bunch of connectors so you can integrate well with your ecosystem. You can get a lot of power and flexibility out of the Aerospike database. We run very close to the hardware, so we get a very good performance based on the hardware. And we're very cloud agnostic. So if you decide that you've got bare metal data centers and you want to migrate into the cloud, for example, with Aerospike, it doesn't matter. We don't care where the data lives, if it's on premise, in the cloud, or in a hybrid. We have different ways of communicating the data between them. We can replicate data between data centers synchronously or asynchronously, so you can get the best of both worlds. So what sort of use cases use Aerospike? And honestly, we're across the wide gamut of industry verticals. So financial services, for example, in particular, if you think about the areas where you need fast data, say fraud detection, I swipe my credit card. A credit card provider has a very, very short time window, typically somewhere between 120 milliseconds and maybe say 3/4 of a second to say this transaction is fraudulent or not. In that time, they have to run complex algorithms. The best ones that we see are typically based on AI and neural nets, deep learning, that sort of thing. But to feed those real-time decisioning systems, you need to load a lot of data. You need to load not just your recent transactions, but the merchant's recent transactions, the recent transactions of the terminal you're running on, all sorts of things. And so you might want to load, say, 100,000 records of data and run a fraud algorithm on it in that very tight time window. And you really want something that gives you that low latency and the scalability that Aerospike will offer to be able to do that. Same thing for gaming. You've got real-time decisioning. Now, this can be in-game state. It can be changing information contained in leaderboards and network states and things like that based on gaming, or it can even be bot detection or fraud detection. So I'm running in a casino. I want to make sure that there is no problem gambling. Someone who can be identified as having an issue with problem gambling, we can identify that in real time in some gaming scenarios and tell them to stop, effectively enforcing that healthy practice. We also have ad tech and martech. Now, we sort of grew up in ad tech. Ad tech is a very stringent industry in terms of latency requirements. When someone shows an ad on your screen, they have a very, very tight window to show that information. It's typically about 10 milliseconds they get to load that information about who is Tim, what sort of interest do they have, and what sort of things have they looked at recently, so that they can show me an ad that might be pertinent to me. And the more information they can load, the more pertinent the ad, the better the chance someone clicks on it, and therefore they get the vendors will give them money for showing the ad. And so the smaller the window you can load that information in, and the more information you can load, the better the results. IoT is another great use case. I'm ingesting sensor data. Now, typically when you're ingesting sensor data from devices, you're pushing that information into a queue. The queue acts as a buffer. Typically, the other end that is consuming out of that queue is a database. That buffer is necessary because databases typically can't keep up with the write load. With Aerospike, because we're so fast at ingest as well as egress, we can keep up with the write load. So you can effectively write directly from the devices into Aerospike without the need for that intermediate layer. that won't buy you anything with Aerospike. It allows that real-time decisioning we've been talking about. Another area is telco. Lots of network packets come in. I need to make decisions on them in real time. I need to know, has this account gone over their balance in terms of data, for example? I need to make decisions in real time. So you can see the common theme across all these verticals is the need for real-time data. And it can be very, very large real-time data, or it can be small real-time data. It doesn't matter, but you know that if you start with Aerospike, it will scale up to the levels that you're likely to ever need. So what's so different about us? How can we do this and no one else can do this? Well, for a start, we have a patented hybrid memory architecture. This is effectively using the SSDs in your system, so the storage device in your system, as a sort of memory. Now, it's persistent memory, so if power goes off on the machine and it comes back on, you've still got all the data there. But it gives you, the way we use it, gives you the speed of memory across those devices, and effectively will give it that scalability and the ability to look up data in real time. I'll touch more on this in a moment, but hybrid memory architecture, where we store the primary indexes in DRAM and the data on SSDs, gives you a very, very scalable, very performant cluster. We have intelligent clients. We want to make sure that everything is as fast as possible. So our clients know about the state of the cluster. They know for any piece of data in the known universe, which server that node, that piece of information will live in. So they can do a single network hop from the client to the server to get that piece of data. And it's got a lot of smarts in there. It knows when the cluster readjusts. It knows how to send information across the cluster and look at the cluster. We're also very good at dynamic cluster management. We want to make sure that the cluster stays healthy over time. It doesn't matter if you grow the cluster or shrink the cluster or nodes fail or an entire zone fails, Aerospike will just keep running. It's really designed for ease of DevOps. Now, this is all transparent to the user. So if you don't like those 3 a.m. wake-up calls, which says, hey, a node has failed in your cluster, use Aerospike. If a node goes down, Aerospike will just take care of it and rebalance the data. The applications will still keep running. I've already mentioned strong consistency. We can guarantee no data loss. We can enforce that under all circumstances. And there's a test out there called the Jepsen test. Aerospike is one of the very few NoSQL databases that passes the Jepsen test. And this is a test that says, can this database, under any circumstances, lose data? They don't care about performance. They don't care about scalability. They care about consistency. And passing that test gives you the bona fides to say, yes, we know we can be strong consistent. We also support a cross-data center replication, so an asynchronous protocol to replicate data between different clusters. Very, very flexible. It can be set up so that I can say, I've got some data in the UK. It's subject, pardon me, it's subject to GDPR. I can't let that data leave the UK. But I have data that originates in the US. I can make that flow to the UK. And if someone touches that information in the UK, it can quite happily flow back to the US because it originated in the US. But the same data, if they touched it and it was a UK-based record, it shouldn't flow back to the US. And so XDR is designed for this level of flexibility and configuration where you can pick and choose what data lives where does data move around to. And it's very flexible in terms of how many data centers. There's no limit on the number of data centers I can join together with the XDR protocol. All right. So I've spoken a lot. I've given you a lot of information and said, yes, we're great. We're scalable. We're flexible. We work really well. I know I'm a vendor and people have distrust of vendors because they say what is going to be predominantly in people's minds. But we've claimed to be the honest database vendor. And so I want to give you some real customer proof points. So the first one is a digital identity management customer. They were using Cassandra. And they've used Cassandra for a number of years. They were very, very smart people. They knew it well. They knew the limitations and the pros and cons. But they were growing. They wanted to take their data volumes from about 450 terabytes to over a petabyte. And they knew that with Cassandra, as they went through, they needed to add more and more nodes. And at higher and higher scales, the cost became prohibitive. So they moved to Aerospike. They did so for the scalability. But you can see what happened with their latency. So on this graph, the original latency is up here. This is the Cassandra latency. It's not bad. It's between, say, 4 and 8 milliseconds. But the thing they didn't like was this variation. This is a B2B business. So when I log onto a banking website and say, I want to transfer money, they'll probably go to this customer and say, is this really Tim? Does all his patterns and everything look good for this being Tim? And so that they've got an SLA on that. And it was 150 milliseconds. And with that variability in the latency Cassandra offered them, sometimes they would miss that SLA. So they moved to Aerospike. Now you can see that average latency dropped here. And so looking at this graph, the latency, the average latency, that's from the client to the server, look up data off storage, and then bring it back to the client. That's that round trip latency dropped to about 200 to 250 microseconds. That enabled them to ensure they never missed that SLA. In fact, they now have a premium service that instead of 150 milliseconds is now at 50 milliseconds, so 3 times faster. And they know they're not going to miss that because they're reading their data from Aerospike. They've also increased their data volume. They're now at 1.3 petabytes of data. And then the interesting thing is look at the cost of their servers. They were growing, and the 200 plus servers is where they would have gone to with Cassandra. They're at 28 Aerospike servers. So a huge reduction in the number of servers, which will save them money as well. Another company is a fraud detection company, very well-known payments company. They were using, in their case, they had 2 Oracle RAC clusters and 360 nodes of Terracotta cache. So this is every time I use their service to transfer money or make a payment, I get a fraud check. That fraud check was done in this system. So their old latency wasn't bad, 1.5 to 2 milliseconds. Their new latency, which I have to label because no one ever sees it down the bottom, is this line. This is about 10 times faster. It's about, again, 200 microseconds round trip time, and it's a dead flat line. Now you can see, not only did they drop their latency by about 10x, they improved their data volume by over 10x, or about 150 terabytes now, and their throughput increased by 5 times. So very, very successful in these customers who need that real-time scenario of data that is quick and very scalable. Okay, so Aerospike has lots of goodness. What I want to do now is focus on the developers for a while. I'm Chief Developer Advocate after all, so the developers are very underestimated segment of many database markets. Everyone who thinks database says, oh, I'm going to make sure it's resilient and scalable and does all these things that has a lot of DevOps value. And don't get me wrong, we do that and we have a lot of DevOps value, as you can see on the right. But I want to talk about the developer side of things. What do developers care about? Well, they want it scalable. They want to make sure that the application can start once and scale as their needs grow. Retooling a database platform. So if you start with the wrong database platform, retooling that gets very, very expensive. So we have it. We want you to start with Aerospike and then grow. It will grow with you as your business needs grow. We want that performance. We want to make sure that a query doesn't take seconds or hundreds of milliseconds. We'd like it to be typically sub-second, and we wanted a flat line latency so that you can rely on it spending that time. As I mentioned, we want it multi-model, so you can pick and choose what is appropriate for your technology. And we want it persistent. Now, typically with a persistent database, as I said, you typically put a cache in front. The problem is that increases your application complexity. You have to make sure that test to see, is it in the cache? If it's not, I need to go across to the database and get it there. I need to make sure I have write consistency and things like that. Caches are inherently fragile and they inherently slow down the application development cycle. Aerospike doesn't have a cache. So therefore, we have persistence with simplicity from the developer perspective. And the database is language agnostic. I can write to it from my favorite client. In my case, I happen to be a Java person. I prefer Java, so I can write to it in Java, but then I can go and read from it in another technology. I can read from it in C or Go or whatever other language you want to read from it in. It doesn't matter. The data is stored in an agnostic fashion so that you can read and write to it from any client. All right, so this all sounds good. How do we get started? Let's say you come out of this and you say, right, that sounds very interesting. I want to go and investigate it. How do I get started with Aerospike? Well, the easiest way is to go to developer.aerospike.com, and there you'll find a sandbox. And the sandbox looks something like this on the right. It gives you a code editor, and you can connect to the database from your web browser. The databases are held in, they're hosted by Aerospike. It's a very small Docker container which runs each instance. but you can get your own database session and play with Aerospike, fully featured database in whatever language you choose, and be able to insert data, read and write data, and play with it. And we'll come back to this in a moment. But that's a very, very easy way of getting started. If you like what you see, come and look at our Jupyter notebooks. These are an extensive collection of samples where we say, here we will guide you interactively through a tutorial about how to use Aerospike. It's great for learning new concepts. After that, I know that me as a developer, I want to play with it. I want to put it on my machine and play with it and break it and do whatever horrible things I want with the database. So you can get a free version of the enterprise download. It's a single node install. It's a single Docker install, and it's really easy. I can connect my IDE to it. I can also do that through Aerolab and Docker. Aerolab is a very easy way of setting up a cluster. It gives you, from the command line, a very easy way to say, I want a 5-node cluster, one simple command, and it'll give you that cluster. Very quick and easy cluster creation and management. All right, so I've downloaded Aerospike. My first job now is to write a program on it. Well, how do we do that? So let's say we've got a 5-node cluster, and we've got our developers sitting there, and they want to connect to it. The first thing you need to do is create the Aerospike client. So I'm going to call create a new client, new Aerospike client. I'm going to pass it null, which I'll come back to in a moment, my IP of one of the nodes in the cluster, and the port, which by default is 3000. Now, what happens then is that my client will go and talk to that one node in my cluster. So it's going to go to a single node. But I've got 5 nodes in my cluster. So that one node is going to tell the client about all the nodes in the cluster. It's going to tell it about all the other nodes that it doesn't know about. So I'll end up with the client knowing about 5 nodes. The client then establishes a connection to the cluster. Every node in the cluster gets connections. In fact, it's a connection pool to every node in the cluster. So that when I go and request data from a node in the cluster, Aerospike will know which node to go to, and it will go and get that piece of data. Now, this is all transparent. All that back and forth communications is just done with that one instantiation of an Aerospike client. So that's great. That works really well. But it's not really production ready, because what happens if that node that I'm talking to falls over and it's not running? Well, if it's not running and I start like this, it's not going to work very well because I can't connect to that node. So typically in a real production scenario, we'll do something like this, where we pass it a set of nodes. In this case, you can see I've passed it 3 nodes, and Aerospike will try each one of them in turn. When it finds one that connects to a cluster, it'll say that is the cluster I want to connect from. I can also do things like pass those in a properties file, and I can parse them with a very simple command. Now, I mentioned that first argument. The first argument I'm passing as null. In Aerospike, almost every API call takes a policy. A policy dictates all sorts of things. It says, how long should I wait? What sort of timeout property should I set? How many nodes should I connect to? A whole different slew of things depending on what you're trying to do. So the policy on a read is different to the policy on a write, it's different to the policy on a connect. But they're very, very important. If you pass null there, Aerospike will give you meaningful defaults. But in production scenarios, you typically want to think about these more. They're so important that you want to make sure that you've got all the right policies set up. Now, for the sake of ease in this webinar, I'm going to be passing null. But in a production environment, we typically don't recommend passing null. And we can talk more about that in a more advanced in a more advanced topic. All right, so we have a connection to a database. We need to know how to store data. The first thing I need to tell you about is, what does Aerospike look like? How do we store the data? So I've got a relational database up the top. So these are familiar concepts where I've got a schema which contains a set of information. The schema typically contains a set of a set of tables. Those tables are broken up into columns, and a row is a single record which has all of those columns. Aerospike has similar concepts, but they're not quite the same. So we have a namespace instead of a schema. A namespace is a storage definition. It says, where am I storing the data? Is it in memory? Is it on disk? Where are my indexes? Are they in memory? Are they on disk? And so on. Inside a single namespace, I have sets. A set is very similar to a table. It's a logical conglomeration of records. Inside my set, I also have records. A record is similar to a row in a relational database. It's a set of information or amount of information associated with a single key. And then that is broken down to what we call bins. A bin is similar to a column. Now, Aerospike is unstructured data. So if I have differences, so you can see in my relational database, I have 2 records. Joe doesn't have a last updated time or an updated at time. In a relational database, that column is null. In Aerospike, because each record is self-describing as unstructured data, I have the same record, but I don't have an updated at. It's not null, it doesn't exist. And as I mentioned earlier, this information can be hierarchically stored. So I can get that information in lists and maps, and I can store very, very complex objects in each one of these Aerospike records. All right, so we now know what a data model is. Let's go and insert some data. First thing we need to do is we're going to go and create that data. So I've got 2 addresses. I go and create them and I put them into a list. So I've got a list of my 2 addresses. I establish my connection to the client, to the cluster. Now, this is a thread-safe connection. I can have 100 different connections 100 different threads. They can all use the same client. I only need to connect once. I then go and create a key. A key always contains 3 parts. It contains the namespace, the set, and the primary key. If you think about a relational concepts, you want schema.table, that's namespace.set, and then the primary key. So it's very similar to what you're used to in relational concepts. I can then go and put my information. Now, this information can contain a whole variety of different types. So each bin has a name, and then it has whatever information you want to store. So you can see Joe is a string, 28 is his age and that's obviously an integer. And then I'm storing my addresses. And then at the end of the program, I'm going to close my connection, just clean up. When I store that information, I've stored it inside Aerospike, and Aerospike effectively stores it in this hierarchical manner. So I have a record, has these scalars, but then it has a list, and inside that list, I have maps. So I've already started using hierarchical information. So when you think about it, this is effectively a document. I've got document information stored hierarchically in Aerospike. That means I can query it and manipulate it as a document. So I can create an Aerospike document client. I can say, hey, go and give me any streets on any addresses. And in this case, it'll give me 123 Main Street and 222 Smith Street. I can also then manipulate. I can set that information. I can also do the same thing as a key value. So same data, same record, I can choose to manipulate in whatever language or dialect is most familiar to me or makes the most sense for this data. So in this case, I'm just using our native key value database, and it works just fine. There is no constraint on not being able to use these on the same data at the same time. Okay, we've got data, we've got a basic program. I want to know if it's fast. I mean, Aerospike makes these wild, crazy claims about, hey, this is a really fast database. Okay, so I've got my sandbox. I've put my code into my sandbox. I'm going to change it a little bit. And so I'm still connecting to the database, but now I'm going to insert 1,000 customers. And I'm going to ask the system, so it's straight Java, to time it. So I'm telling it, get me the nanosecond time at the start, insert a record, and then give me that time in microseconds. When I run this, I see the output in the console, and you can see the insert times. Now, this isn't production hardware. This is running in a very small sandbox inside a small Docker container. So it's, so there will be variance because it's not a production level hardware. So sometimes you'll see a couple of milliseconds, but as you can see, a lot of them are measured in those sort of microsecond ranges that we've been talking about. So yes, it's very fast. Okay, how is it that fast? Everyone comes to us and says, when I go and talk to people about Aerospike, I get one of the most common objections I get is, I don't believe you. How can something be this fast? How can it do all this magic? So I'm going to lift the hood and take you through some of that magic at the moment. So I have 3 nodes in my cluster, A, B, and C. When they come together, they agree on a partition map. We have 4,096 partitions. This is your data broken down transparently to the application into a set of different partitions, and those partitions are assigned to each node. So you can see partition 1 has a master on node A and a replica on node B. Partition 2 has a master on node B and a replica on node C, and so on. And the algorithm Aerospike users will actually divide those masters as evenly possible across all the nodes in the cluster. So you get very good parallelization and an optimal deterministic manner of allocating those partitions to the same nodes. So same nodes in the same cluster will always form that same partition map. It's deterministic. The client also receives a copy of this. It has to. The client, remember, is a smart client. It's trying to do a single network hop from the node, from the client to the node that holds that piece of data. So this map will tell it how to do that. So I would know that if my piece of data was in partition 1, I need to send a network message to node A. All right, so how do we do that? I've got a key. How do I turn that into a partition ID? Well, if you remember our program, we had a new key and we gave it the namespace, the set, and the primary key. What Aerospike will do is it will take the set and the primary key and it will form a conglomerate and then hash that conglomerate. The hash we use is a very specific hashing algorithm. It gives us a 20-byte hash of that afterwards. We call this a digest. Now, those 20 bytes are statistically random. So it's this hashing algorithm spreads the set of digests across the entire plane of those 20-byte keys. So it's effectively random noise. That's really good for us because randomness means that we can use that to pick a particular partition. So we're going to take the first 12 bits of that. 2 to the power 12 is 4096. So that gives us the partition ID. If we always take the same 12 bits, we'll always get the same partition ID for the same key. Same partition ID will give us the record in the table. So without even leaving the client, I can algorithmically determine which node I'm going to. So we're using a constant hashing style algorithm to work out which node every record lives on. Once we've got that, the client sends a network request to the server. As I said, it's got connection pools. It's already got these established. So it's sending that network hop to this server, single network hop. So what happens when you hit the server then? Okay, well, the server has a couple of main layers, and I've really simplified this. There's a lot of complexity in the server, but let's make it simple. So the first thing is I've got an index layer. Typically, we have a couple of sorts of indexes. One is a primary index, which there's always a primary index for every record, and then there's a secondary index. The primary index and secondary indexes can be stored in memory, or they can be stored in disk, or they can be stored in persistent memory. The storage layer is where we're actually storing the data. It's broken up into SSDs, and typically we'll store the information on SSDs, but it can be in memory. It can be in memory stored back by persistence, or it can even be on PMM. Now, typically the best performance we get and the most scalable performance, the best combination, is storing the indexes in memory and the data on SSD. This is our hybrid memory architecture. When we use the SSD, we use it at the low level. We don't put a file system on top of it. And that removes a whole bunch of slowdowns. There's no performance penalties as inodes move around and all sorts of fancy things happen. It just sits there and works as a storage device, and we control what it looks like, how it's stored that information on the devices. All right. So what happens when a read comes in? We did our get, we worked out that our client needs to go across to the server, and we're going to do that single network hop from the client to, in this case, node A. Well, when we do that read, we're going to pass the digest across, say, this is the record I want to read. We have effectively a sprig table. Instead of having one giant primary tree, which was a balanced red-black tree, we've split up so we've got a whole bunch of those smaller ones. Now, we can have as many of these as you choose. It has to be a power of 2. And to work out which sprig to go to, we take some more bits in that random digest, and that will tell us which sprig to go to. So in this case, we've gone to the second sprig, and it said, okay, I know now this tree is my index tree, and it's going to be small because we've broken up a gigantic primary tree into a set of these small trees. It will traverse that tree looking for the digest. So it goes to each node in turn. It's a balanced tree, and it'll find that in log n time. Once it finds that, it will then go to storage and it will read that off storage and send it back. Now, there's no extra things you can look at here and say, you could go and make that faster by doing something else. So effectively, it's single network hop from the client to the server, look up where the data lives in memory, read that information, and send it back to the client. Aerospike's written in C. It's designed to remove as many locks and network contentions as possible. And typically, we're limited by disk IOPS. Now, these are SSDs. We don't run on hard drives. An SSD is very different to a hard drive. I can do thousands or tens of thousands or even hundreds of thousands of reads in parallel and get very, very fast response. Most database vendors treat an SSD as a faster hard drive. And it's true, you'll get a performance boost if you use an SSD over a hard drive. But you don't take advantage of the underlying characteristics of an SSD, and that's what Aerospike does. We need the fact that it can read all of these records in parallel. That's why when we read, we go directly to the disk and read it. We're not reading it out of cache, we're reading it off storage. And that gives us that sort of performance that we're after. Okay, reads are easy. What about writes? Writes are hard, obviously. Well, actually, no, they're not particularly hard. Writes to an SSD are destructive. SSDs have wear and tear, and they occur when you do a write. So we want to minimize the writes to an SSD. We want to make sure that when you write the data, we're not going to move it around later, because again, that will create wear and tear on your hardware. So when we do a write, again, the client will send the request to the server. That server will then go and put that information into a buffer. Now, these buffers aren't big. They're typically, say, a megabyte. So I'll have some part of the buffer that is used. I'll write my new record. And when that buffer fills up, what we'll do is we'll go and flush it to the drive. Now, once we write the record into the buffer, we'll update the primary index. If it's a update, we'll just replace the existing value or the reference to where that record lives. If it's a new write, it's an insert, we'll go and add into the primary index, and then that will point to the new record. In either case, we end up with the record being pointed to. Now, we then go and replicate. So we then go and send a message across to another node. With Aerospike, you have multiple pieces of information, and each one of those is configurable. You can say, how many copies of the data do I want? In this case, I'm using 2. So I've gone to my node B, and I'm going to do the same thing in node B. I'm going to write into a memory buffer, then I'm going to return back. Once both of these have said, yes, I've got the information, I'm going to respond back to the client. So effectively, the slowdown on the write is I've written into a memory buffer, I've sent a network message to another node over established communication channels, written into another memory buffer and read it, and then returned back to the client. So it's really, really fast. Now, these buffers will flush to the drive, and they flush when one of two things occurs. Either the buffer fills up, and remember, they're small buffers, and if we're writing moderately quickly, they'll fill up very quickly, or a second has elapsed by default. You can also force it to flush on every write. So if you are financial service information, it's absolutely critical information, then you can say, I want to make sure these are stored on persistence before I actually return back to the client. There's a performance overhead of that because flushing to any device slows things down, but it's not horrendous. Okay, so that's how we get that speed. That tells you the low latency and the high throughput comes from those read and write paths. Because they're so simple, they're so easy to understand, you can see how we can get that latency and the performance. Okay, what about scalability? I mentioned we can scale up to ridiculously sized petabytes of data and things like that. Well, we typically have a cluster of nodes. So our client will talk to a cluster of nodes. So in this case, I've got 3 nodes, and each one of those nodes has 3 SSDs. Aerospike will ensure that each server node has approximately the same amount of data. We'll distribute the data very evenly across those. So in this case, each one of my nodes will have about 33% of the primary cluster data. Inside each one of those nodes, I have 3 SSDs. We will also ensure that that data is evenly striped across the SSDs so that you've got full parallelization. As I'm going to do those reads that I showed on the previous slides, if I'm trying to do 1 million reads a second, and I try and do that on one device, it's almost certainly not going to keep up. But if I spread those 1 million reads across my 9 SSDs across my cluster, they're only doing about 100,000 reads per second each. Most devices will handle that these days. And so we run close to the hardware and we use these hardware devices to the best of their ability. We make full use of the hardware, and We have very close partnerships with many of the hardware vendors because they love how closely we work with their hardware and the sort of results they get when we use it. All right, so this has been a very whirlwind tour of what Aerospike is. There's all sorts of things that make life easy. For example, tooling. On my client side, I have a quick look, which is a command line tool I can use to go and select data and insert data, manipulate data. I can also go and connect to standard tools. So we have a JDBC driver. I can connect to something like dbeaver, which uses the JDBC driver, so I can query the information and update the information through an IDE. On the server side, we have graphs that are shown through, we have a Prometheus adapter, and we use Grafana to sit on top of that, so you can do visualization and see all sorts of metrics about how your cluster is running, what sort of latency you're getting, bottlenecks, anything like that. I have touched a very small part of Aerospike. It's a very complex product, and there's a lot it can do. I want to give you a quick introduction about what is Aerospike, what can it do, and how does it do it? How do we make all these unbelievable claims? And hopefully by now you can see that they're not actually unbelievable, they're the truth. And we have many customers in production who will attest to that. There's a lot I haven't touched. For example, I touched briefly on lists and maps, collection data types, but I haven't shown you the full power of them. They have very, very flexible and powerful API, which can do a lot of things. So I can manipulate parts of a document, if you will, simply by telling the server how to do it, rather than having to pull the whole thing back to my client, change it on my client, and send the whole thing back. Very important feature. We have powerful expressions where I can put in filter expressions. I mentioned when I was talking about XDR earlier, that you have the ability to select what data moves around. I can do the same thing on any operation. I can say, go and read me these 5,000 keys, but I only care about the ones who have customers whose age is between 27 and 39, for example. I can pick and choose how I'm filtering the data. I can do batch operations. Now, this isn't just read operations. This is full read and write operations in a single core. And Aerospike will distribute those reads and writes to the appropriate nodes that have to do the operations on the data and return the results. I can do queries. I can scan across a table or a set, or I can run a secondary index query. I also have concurrency controls. I want to make sure that I have multiple threads who can update the same piece of data at the same time without treading on each other's toes. So there's a lot that I haven't covered. We also have a whole set of connectors. We can integrate with things like messaging queues, Kafka, JMS, MQs, that sort of thing. We have an Elasticsearch connector. We have the ability to get information in and out using SQL. And we have a very powerful Spark connector that is very, very useful because I can use a lot of parallelization in Spark and divide my data in my cluster into a set of things that Spark workers can operate on. So as you can see, I've barely scratched the surface of what Aerospike is, but hopefully this has given you some understanding of what it fundamentally is, how it works, and the power of it. We would love to hear from you. We have lots and lots of developer resources, and we're getting more all the time. So we have developer.aerospike.com. This is designed for, I'm a developer, I want to go and learn about Aerospike. I want to see, how should I use my C client? How should I use my Java client, my C# client? What sort of programs can I write? Do I have any sample code? We have very extensive documentation at docs.aerospike.com. This is all the configuration, all the metrics, all sorts of good information sits there, which is how to use Aerospike from both a DevOps and a developer perspective. We have a lot of examples on github.com, Aerospike examples. And we mentioned Aerolab earlier. That's that easy way of setting up a cluster. Again, free and open source. Come and use them and have a play. We would love to hear from you. So we've got the Discord community. You can see the link there. And we have an email if you want to talk to us and say, hey, how do I do this with Aerospike? Either come and join our Discord community and post in one of the forums, or come to developer.aerospike.com and send an email to us, and we'll respond to you privately. So if you're running inside an organization and you don't want to put details of your use case inside Discord because it's a public forum, we're very happy to talk to you privately over a private email.
This was awesome, Tim. Thank you so much. And thanks to everybody who attended today. I'm not seeing any questions in the Q&A box. I can give it a minute here and wait for those. We're happy to take those if you have anything or any comments you want to provide us. We'd really appreciate that. We're almost at time. We have about 10 minutes. I'll just give it one more minute here. And if not, we'll wrap this up today. I just wanted to let everybody know who is on today and those listening to our recording. We will be having these webinars probably around 5 to 6 weeks at a time. So I would look for them in the next month or so. Data modeling, scalability, all of the attributes and the information that was there on our presentation today will be discussed in future talks. We do have a question for you, Tim. Is the flush on every write available only in strong consistency mode?
Yes, that's a great question. And the answer is yes. The ability to flush on every write only makes sense in strong consistency. So strong consistency says, I'm going to guarantee never to lose any records. If you're running in availability mode, the point of flushing on every write says, I want under no circumstances for this write to be lost. But it's availability mode. If a network split happens and you're updating the same record and it merges back together, you have the probability of losing data anyway. So it doesn't really make sense to do that flush in the availability mode. So it's only strong consistency mode. We did have it originally in both, but we found that no one used it in availability mode and it didn't make sense for that reason. So it's a great question, but at the moment, yes, it's available only in strong consistency mode.
Okay, great. Got it. We have another question. Is Aerospike on availability mode and hybrid storage a right fit for cache then?
Yes, it would work really well as a cache. So one of the nice things about Aerospike is you can use it as a cache in front of, say, a mainframe. And we have some customers who do this. It's sort of a persistent cache. It gives you that ability to work really well. What we typically find, though, is people who use it as a cache then say, well, if I'm using it on a legacy system like a mainframe, I've got no choice. I want to be able to pull that information down. And typically they want to use Aerospike enough of a cache, they will divorce the mainframe from the traffic. We've got one of the very large financial services information customers who do this. They pull all their information down from the mainframe. Aerospike is their intraday system of record, and it trickle feeds it back up to the mainframe. So they only need a small amount of MIPS on the mainframe. But typically, when you think of a cache, you're putting a cache in front of a database. If it's a more modern technology, why are you having that two-tier architecture? Why do you want to cache in front of a database? A database like Aerospike, which has the speed of a cache, but the persistence and durability of a database, gives you the best of both worlds. So yes, we can be a cache, but it's something where you think carefully about and say, do I really want a cache or do I want just a super fast database?
Here's someone asked another great question. When should I choose Aerospike over another NoSQL solution like MongoDB or Cassandra?
Great question. Both of those are great databases. So there's a lot of databases out there and they all have good reasons for being. And I've been around databases for a very long time, been a developer for several decades before I started looking in distributed SQL databases. And there's no perfect database. Mongo is a great document database, and it works really well, but it has scalability challenges, and these are well documented. It's great if you size for the scale of data that you want to end up with. But if you're growing, if you're starting a new workload and you say, Mongo is a great database, it's really easy to get started with, and then you hit a wall and you discover that Mongo won't scale at the levels that you're going to because your business is growing, you then have to retool. And I mentioned earlier that retooling a database is a very, very expensive and difficult operation. So if you have the sort of workload where you need documents, but you're going to need that scalability, you want to be able to say, I think this product is going to be very successful. I want to start I want to start at the gigabyte level, but I want to make sure I don't hit any barriers. I want to be able to go from gigabytes to terabytes to petabytes, and I want the database to grow with me without having to change. That's one of the reasons I'd look at using Aerospike instead of Mongo in that case. Cassandra, same sort of thing. It's a very good model. I haven't touched on a number of copies of the data. Aerospike, I mentioned, has strong consistency. In a distributed database, typically, if you want to be able to handle the loss of one piece of data, and you're using a quorum-based technology like Mongo, like Cassandra, like almost all consistent databases out there, you need 2n+1. So you need an odd number of copies. So to lose one piece of data, you need 3 copies of the data. To be able to lose 2 copies of the data simultaneously, you need 5 copies of the data. Aerospike invented our own data, our own consistency. We can do strong consistency with n+1. So I can have 2 copies of the data if I need to lose 1 copy at any time. If I want to lose 2 copies at any time, I can do 3 copies of the data. So it saves you a lot of money in terms of the actual physical hardware. Our nodes can be incredibly dense. We can store, I think I've got one customer in production with 80 terabytes a node. Cassandra strongly recommends you don't go above a terabyte or 2 per node. So you get a lot of nodes in the cluster as you're growing the data. If you are up in the many terabytes or petabyte range of data, you have enormous Cassandra clusters. That costs a lot to maintain, it costs a lot to upgrade, and there's all sorts of operational procedures that are bad with that. So that's some of many reasons why Aerospike would be better than Cassandra in some use cases. We're also strongly consistent. Cassandra is an AP database. They cannot guarantee consistency. They don't pass the Jepson test I mentioned earlier. So many reasons. If you have specific questions about a use case, reach out to us. We'd love to have a chat with you. And I'm very pragmatic. I don't believe that Aerospike is the perfect database for every situation. There are great use cases for Mongo. There are great use cases for Cassandra. There's great use cases for Aerospike. And I'll be very open and honest and say, no, go and use Mongo for that. I think it's a great database and it'll fit your use case better.
Okay. Next question. Is there a way to handle hard deletes on CE?
On the community edition, there isn't, by hard deletes, I'm assuming you mean, I want to make sure that data goes away and never comes back. Now, this requires a feature called durable deletes. A delete in a NoSQL database with multiple copies of the data is a difficult concept. Think about it. I've got 3 nodes, 2 copies of the data. Let's say I've got a copy on A and a copy on B. B goes down. It's still got a copy of that data. And remember, our nodes are persistent. So when it comes back up, it will know about that copy of the data. Aerospike will work that out and say, oh, B's gone down. I need 2 copies of the data. I'll make a copy of that piece of data from A to C. I'll end up with 2 copies on my working nodes. I go and delete that node. I go and delete that piece of data. It goes off A, goes off C. That's great. B comes back some point later. It's still got that piece of data on it. It doesn't know it's been deleted. The cluster doesn't know it's been deleted. So effectively, what we need to do is not actually delete that data. We need to tombstone the data to be able to say, hey, I need A to know that that record has gone. So if B comes back with a good copy of the data, A will say, my tombstone is later than your good piece of data. I'm going to remove that. And that's a hard problem to solve. So that facility exists at the moment only in EE. It's really designed for consistency and those enterprise people who can't handle records coming back. And so it's a great question. But yes, at the moment that facility exists only on the enterprise version of Aerospike. These are great questions. I really appreciate the interactivity.
They're great. That community edition too, we encourage you to go there if you are exploring that or if you have any questions on that. If you're in our Discord community, you can ask us right away. And if not, and you feel more comfortable, you can actually send those questions to developer@aerospike.com. So please feel free to do that. We do want to hear your feedback on that.